In this video, I will tell you how I always manage to get the sign correct in a cross product. I call it screwdriver rule or bottle cap rule. I never understood why textbook have to teach in such an abstract way and not based on general life experiences. Anyway, let us start. To the right, we have golden rules of the cross product of unit vectors. And this is what we need to figure out by our method. Now, we will need to sort of memorize the x, y, z axis configuration that is shown on the left. It is not very challenging though. From the graphs, you have already seen x is always to the right, y is upwards, and z is towards you or out of the page. Just look at the room. X is right, Y is up, Z axis is towards you, and you can play in the room. Now that you have memorized the configuration of X, Y, Z axis, let us see what is screwdriver or bottle cap rule. As the first case, we will find a way to remember unit vector k is equal to I cross j. We draw the graph of x and y axis. We also show the top view of screw, or consider as a bottle cap looking from the top. Since it is I cross j, we like to get I to j by moving counterclockwise. So if we were to use a screwdriver or a bottle cap, moving counterclockwise, it loosens the screw or the bottle cap and move out of the page. Since out of the page is considered positive, it is positive in unit vector k. It is that simple. Won't you agree? Let us practice more to get the confidence. Now we focus on unit vector I is equal to j cross k. Here again we draw y and z axis and see that j cross k means going from y to z direction, and this will result in motion on the right, and since right is positive x, we will get positive in I, which means j cross k gives you positive unit vector I. Now we focus on unit vector j is equal to k cross I. Now we draw x and z plane, it's like a floor, and we place the water bottle. And now going from k to I will essentially means moving up, and up is positive in j, and hence k cross I gives you positive unit vector j. I hope that is easy to remember. Now let us focus on proving these three cross products. You can pause this video and do it yourself. However, let me continue verbally. For the first case, j cross I, we look at the front wall, which is yx plane. And then as we move from j to I, based on the screwdriver rule, we are going inside the wall. And that is against z direction, and therefore minus unit vector k. For the next case, k cross j, we are looking at the left wall, which is yz plane. Now as we go from k to j, we are again going inside the left wall, which is against x-axis. So it is negative I vector. Now we consider the third case, which is I cross k. Now here we are looking at the floor. As we move from I to J or I to K, we are going inside the floor, which is against y-axis. So it is minus unit vector J. I hope that makes the things quite simple. Now we give some real life examples where we are asked the direction of the cross product, namely, what is the direction of the torque or angular momentum. Let us look at the following example. Finding the direction of torque, which is cross product of R and F. All the vectors are shown in the figure. We draw R and F separately so that they start from the same point. Now we want to go from R to F, and this is the way to go, counterclockwise. Based on the screwdriver or bottle cap rule, it is out of the page, and therefore the answer is direction of torque is out of page. As a next example, here we are asked to find the direction of angular momentum, which is R cross P. We are provided R and P as shown. To do this, we draw R and P separately so that they start from the same point. Now we want to go from R to P, and this is the way to go, clockwise. So based on our screwdriver or bottle cap rule, it goes into the page, and therefore the direction of the angular momentum is into the page. In yet another example, we are required to find the direction of the angular momentum. We are given the vector r and vector p and the distance of closest approach b. Again, we draw r and p separately so that they start from the same point. Now we want to go from r to p, and this is the way to go, clockwise. Based on screwdriver or bottle cap rule, it is into the page, and hence the answer is the direction of momentum is into the page. This happens to be very interesting example, which will be clear in a moment. So we go one step further and evaluate the angular momentum. We find the angle between R and P, which happens to be 180 minus theta. We did some geometry to get that answer. And then the angular momentum is R times P times sine 180 minus theta. Sine 180 minus theta is sine theta, and R sine theta is B. So we get a final value of angular momentum is P times distance of closest approach, and this is a very cute answer. I hope you have enjoyed the video. If you have your own way to figure things out, please stick to that. Especially if your exam is in 1 or 2 days, you do not want to learn and get confused. To all other, try this method and see if it works for you. Bye bye.